Welcome. I want to show you how to run a multiple linear regression. So I'm going to share my screen. And we'll use the SESI data, which is the same data that you'll use for our quantitative lab and inquiry 2. So let's say I want to know how active and collaborative learning and student-faculty interaction predicts gains in general education. But I want to control for being an English language learner and for being married. So let's show you how to do that. I'm going to go analyze. A regression and then linear. And I'll have to reset this. I was playing around in here a minute ago. Now I'm going to make these, I'm going to right click on and just show the variable names. To me, it's easier to find things when it's in the variable names. So let's put in, I was thinking married was up here, but maybe it's not. Oh, you know what? Why don't I make it in alphabetical order? Sorry, this is such a big data file. It's hard to find things, but I also think it's valuable to see all the kinds of things you could use. So Mary, I better right click that and make sure this is what it is. Are you married? 1 is yes, 2 is no. So this will work. It's a dichotomous variable. The only thing I can use in multiple regression are interval level variables called scale in SPSS, those things with a ruler, or a dichotomous variable, something that is either, it's an either or, either you're married or you're not. The same with English language learner is a dichotomous like that. Either you're an English language learner or not. I'm gonna, because I know this better by the order that it is in the file. I'm going to put it in that order for finding my English language learners because I think they are near the bottom. Is English your native, parentheses, first language? Let me make sure how that's coded. Yes and no. Yep, so that's a good one. And then I know there are these scales, active and collaborative learning. And then student-faculty interaction. Okay, so with all this in the equation at the same time, what I'm going to get is the unique contribution of each of these variables in a regression coefficient. And I'm going to get the R squared, which will be the percentage of the unknown that this set of variables predicts. But I need to find my dependent variable. So let's I think I want to do gains in general education, my very last variable in the data file. And I'm good with it like it is, so I'll say okay. I'll share my screen. Share. Yeah, now I was doing another regression earlier, so I think I have a second one there, but let's look at what this gives me. This variables entered, removed is unimportant to me. The model summary is important because this is where I get my R square. So you can see the R square is 0.168, which means this set of variables explain 16.8% of the variance in gains in general education. So we might think of it as like of all the things that predict what students, what promotes learning in general education, I've kind of honed in on 16.8%. I've sort of cleared up the unknown for 16.8% of that. So there's a bunch more. What is that, like 83.2 that we still don't know in terms of what predicts gains in general ed, but we honed in on a bit of it with this set of variables. Then I look at my ANOVA table just to see if it's significant, and it is. So I would report this F And I would report significance less than 0.05, or you could even say less than 0.001 for this. It's just like everything else we've learned with significance. In order for us to say this likely happens in the rest of the population, significance has got to be less than 0.05. And it is, so we're happy. So we report the F and the significance level. And now this is usually what I think is the most interesting part, and that's the coefficients. And so we say, we first look at this significance column and we say, oh, look at that. Everything is significant except, are you married? So married, we would say, we don't think married predicts gains in general education, but let's look at the standardized coefficients, the beta. And so is English your native first language? And it's a kind of a small regression coefficient, but it's positive. So it says students who are English language learners, oh, you know what? We have to look and see how this was coded. You might remember how it was coded, but I'm gonna do a new share and look back and see what was 1 and what was 2 for English language, for is English your native language. So that, could have caught that when I was first running it. But this is what happens. You get findings and you think, what in the world does that mean? And you have to dig back to the data file. So is English, I think it's this one, your native language? Yes. Yeah, that's what I thought. 2 was a no. And so because it's a positive number, it means the regression coefficient is positive. It means as we move from the 2, that means like not having English as my native language gives me or predicts gains in general education learning. So students who don't have English as their native language are reporting learning more in terms of gains in general education than students who do have English as their native language. So let me get out of that. I'm going to share again. I guess while we're here, no, married didn't even matter, so it doesn't matter. We don't need to look that up. Let's look back at my output. Okay, but these are the ones I'm really interested in: active and collaborative learning, student-faculty interaction. So those are both significant. Active and collaborative learning has a regression coefficient of 0.156, and student-faculty interaction has a regression coefficient of 0.290. So of all these variables, the one that is the strongest predictor of gains in general education are frequency of student-faculty interaction. But active and collaborative learning also predicts, and so does not having English as your native language. So what I would report these regression coefficients and their significance. You could report the whole table if you wanted to, but the key things are those, the ANOVA F and significance, and this R squared. Since we have such a big sample, we maybe should use, some would argue we should use the adjusted R squared. I think that, well, since they're both the same, it doesn't really matter. But when you have I kind of learned that if you have a sample over 1,000, then you should use the adjusted R squared. Usually they're like just a tiny bit different. Okay, I think that's, I think you know how to do a multiple linear regression now. And if you have questions, reach out for some help.